So what are we going to be alternating around?
Line.
Well, so notice we got interior and exterior for the pair of lines. The alternating is going to be across this. It'd be nice if there was a word for this line that goes through those other two lines, wouldn't it?
Yes, there is.
There is. It's called a transversal. So instead of having to awkwardly talk about it, one line that intersects through two other lines is called a transversal.
Would that make it perpendicular?
Not necessarily. I mean, once you look at those angles, do they look like 90-degree angles?
No.
It can be, but it's more that it's going through two lines like that. And usually we're going to focus on a transversal through parallel lines. And it looks like it. Don't those lines look like they're parallel? Okay, that's what we're going to focus on because that's more useful. But the transversal is that line that we go through. So when we talk about interior and exterior, that's the pair of lines. Alternate and same side is referring to which line up there?
Parallel.
No, remember we already said interior, exterior is the parallel ones.
Transverse.
The transversal. Okay, so I want you to think about this. Here's angle 2. That's interior, right?
Yeah.
What would be alternate side of the transversal and on the interior? Peyton?
5 or 8.
Are those on alternating sides of the line and on the interior?
Yes.
Yes. So angles 2 and 8 are alternate interior. Raise your hand before you just share out. Hey, Jaden, have you taken any notes on any of this, my guy? I want to see your notes after class. Okay. Raise your hand to share out, but does anyone see another alternate interior angle? Addison. Anybody want to push back on 5 and 3? Anybody want to ask a question about 5 and 3 then? Yes, Maddie.
I was going to ask, so like on the inside of the line, that's where the interior is.
Yep, interior means inside. Okay, so it looks like we're in agreement. Angles 5 and 3. Yes, Nathan.
So for alternating, it's just going diagonal.
Was going onto the alternate side of the line, right? Alternate means on the other side.
Like a rotation.
Kind of. I would just think about it as if one's on top, the other one's on bottom, or if one's on the left side, the other one's on the right side. Right? Alternate side. Okay. Let's do this. I want you to take 2 or 3 minutes, talk with your group, come up with the alternate exterior and same side interior angles. See if you've already tried that. See if you can come up with the answer, or check your answers, and if you didn't, try it now. Where's B? There is nothing written on your paper. That's just a lie, dude. No, you didn't. Being involved in the conversation, you're sitting there putting the protractor on Caitlin's wrist instead of being a part of the conversation. Let's be engaged. Let's talk about the math. Up with yours. So we all in agreement? Jordan? Okay. Jerry? So if you have alternate, which is on the opposite sides, what do you think we mean by same side? So would 2 and 5 be on the same side and on the interior? Well, so remember, alternate meant alternate sides of the what? But alternate sides of what? The transversal, right? So when we say same side, we mean same side of the transversal. Are 2 and 5 on the same side of the transversal? But we're talking about the same side right now, dude. We're talking about the same side interior. That's what they were asking. Does that make sense? Thank you. Thank you. All right, can I get someone to share with their group? I want to pause because I'm seeing the same hands go up over and over again. I want active collaboration from multiple people. I need other people to share their ideas. Like, you literally have a grade tied to this. I'm telling you what to do to be successful. I need someone besides those I've heard from today. Kari, I haven't heard much from you. Give me an alternate exterior. 6 and what? 6 and 8. All right, does anybody want to add on to or push back or ask a question about? 6 and what? 4? Did you mean 6 and 4?
Yeah.
Okay, so look right here. What's the relationship between 6 and 8? They are vertical angles, right? We have to look to the other side. Now, they are alternate, but note, listen, are both 6 and 8 on the exterior of those pairs of lines? No, right? Those are things we want to notice, right? So 6 and what again? 4. So someone else I haven't heard from much. Kyla?
1 and 7.
1 and 7. Anybody want to ask about or push back on? Those two? Jordan. Emily. Whole class conversation only right now. 1 and 7. Anybody want to ask about or push back on? Same side interior then. Alright. Here, see people's hands up. I've already heard from Taylor.
2 and 5.
2 and 5.
I got it.
Anybody want to add on to or ask a question about or push back on that one? You want to push back on 2 and 5?
No, I'm gonna add on
Okay, what do you want to add on to?
3 and 8.
3 and 8, same side interior. Alright. What are your questions up to this point? Yes, Maddie.
Okay, so opposite 2 and 3.
2 and 3?
Same side interior.
Okay, same side interior. So, is that because they're on the same side of this line right here? And because they're on the inside of the parallel lines? Okay. Anybody want to offer any pushback on that, or maybe start to think, hey, maybe that is alternate interior, or same side interior? Joey, when you come back, you gotta knock on the door, man.
I did.
Nobody heard you knock on the door.
Oh, yeah.
Anybody want to add on to, or does anybody want to maybe agree with that, or push back on 2, 3 being same side interior? 2 and 3, yep. Alternate, what do you mean by alternate? So I think that this is coming into a language, and we need to pay attention to this, because what Maddie was referring to is that 2 and 3 are on the same side of this green line right here, right?
They're not alternate.
But they're not alternate in respect to what? Say that louder. The transversal. Remember, when we're talking about alternate and same side, that's in reference to the transversal, right? And so those would be on alternate sides of the transversal. The interior and exterior is in reference to the parallel lines. So our 2 and 3, same side interior.
No.
Raise your hand if you think 2 and 3 are same side as the interior. Okay, so Joey's in agreement. No one else? Okay, so Joey, and this is what we were just focusing on discussing. Those 2 and 3 are on the inside of those parallel lines, right? But when we say same side, we mean same side of the transversal. The transversal is here. Are 2 and 3 on the same side of the transversal? No. So they would not be same side interior.
Hey, I thought when you were talking about same thing, I'm like, when 3.
Say again?
What? When it said same side, I thought it meant 3.
Right, but that's what my point is. Alternate and same side are in reference to the transversal? Is it on the alternating sides of the transversal, or are they on the same side of the transversal? Okay, now I do want to point this out before we continue from here. Does anyone know the most accurate language we could use for angles 2 and 3? They are, say it again, Barely. 2 and 3 are adjacent to each other, right? They are adjacent to each other. Okay, so here's where we're getting into lesson 5. Lesson 5? Sorry. Lesson 5 is what I'm doing with my Algebra 2 class. We're getting to lesson 2 right here. And so what we are learning about is actually a lot. We'll talk about these learning goals. I created my own learning goals that's a little bit less. You see all these key terms? That's a lot. We will use these key terms regularly though, so you need to be comfortable with them. 1. 2, let's start here. Notice how we're talking about the transformations of translations, reflections, and rotations. Take 60 seconds, identify each of these, right? So yeah, identify each of these as either a translation, a rotation, or a reflection. Okay, so look at each of those as a translation, a rotation, or a reflection. Jay, you can call that. We're gonna ask you to do. You're doing that warm up right here. Identify those as translations, rotations, or reflections.
On number 1, start off. I think number 3 is translation.
So we felt comfortable with 2 being a reflection, but not sure about the rest?
I say translation. What you think,
Okay. So let's look at number 1. Is number 1 a translation, a rotation, or a reflection?
A translation.
Translation? Can anybody describe to me how it's being translated? So if, let's say I start up here. How is that being translated? Is what?
Because it's sliding down.
Is it just sliding down? And so it's translating down and it's translating to the right. So we say translating, we're always talking about up and down, left and right. Okay? So I will point this out. Could I have said it was translating to the right and then down?
Yes.
Either one would have worked, okay? So what about 2? What are we looking at there? Reflection? Anybody think anything other than reflection?
No, because they looking at each other.
Okay, so explain to me how this is a reflection.
They looking at each other.
It's
like you see a mirror.
It's like
You
looking
see
at
yourself.
yourself.
So one of the things I will point out is this. You actually always need something to clearly define that reflection, and it's literally called a line of reflection. So I can draw a line of reflection there. Notice here is that smile, right? You see how far away that smile or that point on the smile is from this line of reflection? It's the same distance to the other side.
So it's basically like a coordinate grid.
There is a connection to a coordinate grid, which is what this whole unit is about, yeah. So there's a reflection across that line of reflection. All right. So then 3 becomes a what?
It's some woman outside.
It's coming to get you.
It's a what?
It's a lady outside.
Okay. Number 3 is a what again?
Rotation. There's somebody behind you.
Okay, number 3,
Rotation.
rotation. Now, I will point this out. Let's say I rotate from here. Doesn't this point end up here? And then this point ends up here, and this one here. And so it would look like this. Whoops. So is it just a rotation? After that rotation, what else had to happen? It also had to be translated. So you can have combinations of transformations. You would want to be able to picture that, right? But if I rotate, it would just end up right here. So to get to this, it had to be a rotation and translation. Yep. We would want to note that. Say again. I'll take care of it. Okay. I definitely plan to get further than this today, but it'll be okay. So here's what we're starting with, and we're only going to take a couple minutes to get into this first part, but we are learning about perpendicular line segments and perpendicular bisectors, and it's going to help us and recall features of geometric figures. We'll talk about bisectors when we get there, okay? Not yet. But I'm going to teach you. Notice that's the objective for the lesson today, is to get there.
Teach it.
So, really quickly, here on this getting started, do your best to draw a right angle.
Wait, doesn't drawing actually
Do your best to draw a right angle. So this should not take us but like 20 seconds to do our best job of drawing a right angle.
Oh wait,
Not the right triangle, just the right angle. Erase the hypotenuse. Say again. You have to use what? Tools. Okay. Alright. So we should have a right angle there. Excuse me, I am loud enough that I know you can hear me. You should have a right angle there. But Lillian brought something up. What were you saying that we need here? And I think this is what Peyton was saying earlier too. I said draw, so you had to use tools. Jordan, I'm teaching. You had to use tools, right? And so we're trying to draw a right angle. If I just wanted something that was close to a right angle, what would the language have been? Sketch, right? Okay? And that's fine, right? But if I say draw, you're supposed to use tools to do that. How can you check to see if you actually got a true right angle? Use your protractor, measure it. So use your protractor and measure it. Did you get an actual right angle? Not a ruler. You have to use a protractor to measure angles. You got an actual right angle? Did you use this to do that, or did you just get it? Oh. It's not quite how we're going to do it. Okay? So. Alright, let's bring it back. Hopefully we've measured it. Did we get a right angle, or at least close to a right angle?
Yeah.
Pretty close? Okay. Now, I will say this, if you had sketched it, right, because Lillian kind of used her tools, which is good, but if you just sketched it, how close do you think your angle would have been to a true right angle? Not very well, right? So what we're going to learn about within this lesson is the actual proper way to create a square, which what has to be true about the angles in a square? They have to be perpendicular, so the angles are
Parallel.
so listen, line segments can be perpendicular, but the angles would measure what angle measured?
Right.
90 degrees, which is a right angle, but when I say what's the angle measure, it's 90 degrees. Okay, but when I say measure, that's what I'm saying. Jordan, I should not see your underpants. Pick your pants up, and this should be the only time I have to remind you for the rest of the week. This is getting ridiculous.
Or the rest of the semester.
I don't want to get too crazy with it. So, we're going to learn more about this in a second. So I want you to notice, right, we've already talked about, excuse me, listen, a protractor. What do we use protractors for? To measure angles. What do we use compasses for?
Measure.
To
create
create a
Okay,
circle.
do you have to create an entire circle with a compass?
Yes.
You can just do an arc, a part of a circle. So a semicircle is a full half of a circle. It doesn't even have to be a full half of a circle. It can just be a small piece of a circle. Chill out and stop. Okay. And then we're going to use straight edges as well. So in this lesson, you're going to learn how to construct geometric figures and be exact with our measurements. You may start to pack up, quietly stop, leave the calculators where they are. Jamie, leave the calculators where they are. Leave the rulers and protractors where they are. I will collect them. Just pack quietly. I didn't say get up. Grab a seat. I did not say get up. Can you not wait till they're voting? You read the vote.
Are you interested in astronomy? Do you like math or learning about outer space? That sounds like something for you. First thing you need are
Excuse me. I stopped so that you could listen to the announcements, not
and
talk.
don't forget to tag them in all of your homecoming pictures. Have a terrific Tuesday and go Cubs!
Alright, pause. When we come back tomorrow, y'all, we got to get into this lesson. It took us way too long to get through a lot of that stuff. So tomorrow we are going to get into activity 2.1, learning about how to create a perpendicular line. I'll make sure we have plenty of compasses. I'll talk to other geometry teachers. So we'll get through all of this, hopefully. I need to check to see if you can do that review yet. Don't worry about that practice assignment yet. Have a good rest of your day. If you can get just the rulers or just the calculators, I'll clean up all the other stuff.